My name is Andreas. I work at NewRetex. We are a textile sorting company. We make sorting lines for textiles. My personal role at the company is a technology development engineer, which is also how I got involved in the STREP project. I work on developing sensor technologies and traceability technologies for our sorting lines. NewRetex as a company was founded 4 years ago. We've been developing a sorting line using technologies from other industries and combining it into a complete package that allows for efficient and highly reliable textile sorting for recycling. Our sorting line is able to use X-ray sensors and AI to detect the hard parts within the textiles. This includes both things such as buttons or zippers in materials like hard plastic or metals. It kind of works like an airport X-ray. It shines X-rays through the textiles and as the textiles are passing on the sorting line. We then get an X-ray image of each garment that we sort, and using AI, we can identify the hard parts in these X-ray images. When we have then found the hard parts in the X-ray, in the textiles, we then need to somehow remove the hard parts. This is a bit more complicated task, and we are currently experimenting with different cutting mechanisms and different system designs where we can kind of extract the hard parts, buttons and zippers, without actually destroying the garments and ruining the fibers too much. So the trick here is really to find a gentle way of removing the accessories so that we can still utilize mechanical recycling machines. So our sorting line actually sorts 2,000 pieces per hour in average operation, and it doesn't need to go to lunch or go on vacation. So it will be 2,000 pieces per hour up to 22, 23 hours per day. How many days a year you want to operate a sorting plant. A single operator can manage 2 sorting lines, which will then total out at 4,000 pieces per hour. And that is roughly the same as 1.2 tons per hour for one operator. So if we want to compare this to a manual sorting plant, a manual sorter can roughly sort 100 to 200 kilograms per hour, depending on how the operation is set up. And that kind of makes our system 6 to 12 times more efficient if you only measure it in terms of labor cost. Furthermore, it's important to note that our sorting line can not only sort much more efficiently compared to the labor needed, but it can also sort according to parameters which is not really possible to sort manually. And here I'm talking about material composition. Detecting specific blends of materials can be quite tricky using only manual labor, because you cannot necessarily know if it's a 50-50 cotton polyester blend or it's a 70-30 cotton polyester blend, or if it contains elastane in very low percentages. We're able to do this with our sorting line, and what really comes out of this is that you are able to get really accurately sorted fractions that is not possible to obtain through manual sorting if you look at parameters such as material composition. So this allows you to actually unlock recycling streams that are not possible to tap into today with a manual sorter. Because in chemical recycling and a lot of mechanical recycling purposes, you need a really high purity. This can only be done with an automatic sorting and sensor-based sorting. Then it's also maybe important to note that the operators of the sorting line will of course have a different job. They will be doing different tasks compared to an employee at a manual sorting plant. The job will be, managing the sorting line, meaning filling it up with textiles and removing the containers of full textiles, and removing the occasional stock item in the sorting line. This is a very different task, and I would say much more nice work compared to the highly repetitive task of standing all day and sorting through textiles manually. There is still a challenge However, in the pre-sorting, which is still manual today, we're working hard, and it's really the next big thing that we need to overcome is automating the pre-sorting. And once we get that task covered, we can completely automatically sort the textile waste. And from the perspective of a manager of a sorting plant, if you purchase automatic sorting lines for your sorting plant, it not only allows for a significant reduction in labor costs, but it also opens up an entirely new market for your output streams, since you can now begin to sort textiles according to recyclers parameters, meaning that you can tap into the chemical and mechanical recycling streams that are kind of growing in the market right now, and have an alternative to the kind of traditional business as usual approach that is struggling today in the textile sorting industry. Definitely say there is a deeper magic involved, but in reality, the magic is just sensors and AI. We use 3 different sensors on our sorting line. We have a high resolution color camera, we have a near infrared sensor, and then we have an X-ray sensor. Each of these sensors gives different types of information, and we use different types of machine learning or AI to extract information from the sensor scans. And all this information we then combine to make a good sorting decision. So in the case of a cotton shirt, we can use the color camera to take an image of the cotton shirt, and we can use AI to see, okay, this might look like a cotton shirt. We're not entirely sure, but it kind of looks like a cotton shirt. At least we can see that it is, let's say, white. We then have the near infrared sensor, and by using this sensor, we can measure the material composition of the garment. So let's say it's a cotton shirt. Well, then we use the near infrared sensor to detect that it's a cotton shirt. If there's elastane in it, we can also detect the elastane. Then it passes through the X-ray sensor, and here we get the scan of the material looking at the hard parts. This allows us to see all the buttons in the shirt, and now we can combine all the information we have, and now we will, with a very high certainty, be able to say that this is a cotton shirt, a white cotton shirt. Furthermore, we also get the mass or the weight of the garment using the X-ray sensor. So in this way, we can use different sensors and different algorithms to extract a lot of information from each piece, 2,000 pieces an hour per line. And for each piece, we can then decide where do we want to sort it, how do we get the most value out of this item. It allows us not only to sort according to material composition, but also make predictions about the object type, and this allows us also to say something about the expected value in resale for each garment that we sort.